tube of the telescope. Here is the front. So let's suppose you're looking at Jupiter over here. Okay, here's Jupiter. It's like red dot and stuff. Okay. Okay. So the light from Jupiter or whatever you're looking at is coming like this toward the telescope. It comes in through this window. Once it comes in through this window, there's a mirror in the back of the telescope that has a little hole in the middle of it. So there's a mirror back here. It's a curved mirror. The light comes in, it bounces off this mirror, and then comes forward. And this is curved in such a way that light coming straight in like this bounces and hits this mirror right here. So I'm going to call this mirror 1, and this right here is mirror 2. Okay? So it passes in like this, bounces off here, comes in, bounces off here, and then it's just the right curvature that it goes through that hole that's in the middle of that mirror. There's another mirror right here in the star diagonal. Mirror, I call it mirror 3, I suppose. And then from there, it comes down, and let me draw another line here so you get a sense of boom, 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 like that. Bounces right here, so you get these light rays. And then over here, you've got your eyepiece lens. Okay, so there's a lens right here. This is your eyepiece lens. So you basically have 1, 2, 3 mirrors. These are like the important mirrors as far as focusing the light. This one is just to make it go at an angle to come so it's more convenient to look at it, okay? And this is a lens. So there's 2 important mirrors and the lens. And this is called the eyepiece lens. And then you look through right here, okay? Now, what gives a telescope magnifying power? What gives it magnifying power is the combination of the curvature or the focal length of these lenses and also the focal length of that lens right there. So these mirrors and the focal length of that lens right there, okay? So in my Physics 202 class, we talk a little bit more about optics and how to calculate the focal length and that kind of thing. I'm just going to kind of tell you what the formula is right now without going into detail about how it comes about. But the magnification of a telescope is approximately equal to the focal length of the objective mirrors. These are called the objective mirrors right here, divided by the focal length of the eyepiece. So focal length of the objective mirrors or lenses. In this case, it's a mirror. And this is the focal length of the eyepiece lens. And that gives you the magnification, okay? Now, you can't change the focal length of these mirrors. They're kind of fixed in there. They're just the way the telescope is designed. You can change what eyepiece you're using. And I've got this bin here. This is the expensive stuff, or the lenses. I've got bins of all different lenses with different focal lengths that are going to go in the back. Okay, so I have several different ones in here, several different ones in here. By changing this, you can change the magnification. So you can see here, if you put a long focal length lens in the eyepiece, you're going to have a small magnification. If you put a short focal length lens in here, you're going to have a big magnification. Okay, so the smaller number focal length you put in here, the more magnified an object is going to be, but also the harder to find it it's going to be, because you're really magnified and you're going to, excuse me, it's going to be harder to find an object because you're kind of zoomed into a little portion of the sky. So usually when you're setting this up, you want to start out with a large focal length lens here, so it's not magnified much, so it's easier to find the thing. And then once you're kind of zeroed in on the thing, you can swap it out and put in different shorter focal length lenses there. Okay? And so, like, for example, this one right here, this lens has a focal length of 40 millimeters, 4 centimeters. That's a pretty long focal length lens. Whereas this one right here has a 17 millimeter focal length, so it's shorter. It's less than half of the focal length. So this will give you over double the magnification than the long one does. Okay? And then I got several more in there. So let me just start with this big one right here. There's caps on these, so you have to pull the caps off. And it's good to keep the caps organized so you don't lose them, because it's really important to keep these lenses covered so you don't get smudges on them and dust and whatnot. So you'll take a lens like this, and this will fit into, and I'll kind of rotate this so you can see what I'm doing. This will fit into the star diagonal up here. There are these little thumb screws. You can kind of back these out a little bit so it slides in nicely. And then it just kind of clamps down in there just like that. And you'll want to make sure it's screwed in tightly, give it